Graph the quadratic equation in two variables by plotting points. Plot 7 or more points, clearly label and scale the axes. Alright, so what we'll do here is I'm going to create a table of values, and we will evaluate using that table and use that table to plot some points and see the shape of this. Alright, so the first thing I'm going to do is set up some x values, and then we'll evaluate y is equal to x squared minus 6, and then we will write ordered pairs in the form x, y, and plot them. So I'm going to start with the points -3, the x values -3, -2, -1, 0, 1, 2, and 3. So that'll give me 7 points. So then the y value would be, for the first point, -3 squared minus 6, and that's 9 minus 6, which is 3. So we have -3 is the x value, and the y value is 3. And let's repeat this for the other 6 x values. -2 squared minus 6 is 4 minus 6, which is -2. If x is -1, now we have -1 squared minus 6, which is 1 minus 6, or -5. If x is 0, we have 0 squared minus 6, which is 0 minus 6, or -6. If x is 1, we have 1 squared minus 6, which is 1 minus 6, or -5. If x is 2, we have 2 squared minus 6, which is 4 minus 6, -2. And if x is 3, we have 3 squared minus 6, which is 9 minus 6, which is 3. And so we have the point 3, 3. Alright, looking at my values, my x minimum is -3, my x maximum is 3, my y minimum is 6, my y maximum is 3. So from that, I'm just going to use a standard scale, and I'll just mark off every 2. So there's x equals 2, 4, and here's y equals 2, 4, and 6. And same in the other directions. Alright, and I'll plot the points in blue. So let's see, we have -3, 3, -2, -2, -1, -5, 0, -6, 1, -5, 2, -2, and 3, 3. So notice that this graph is non-linear. We cannot draw a line that passes through those points. If we draw a curve that passes through these points, we would get something that looks like this. And it will continue upwards on both the left and the right. And this shape is called a parabola. And in fact, the graph of any quadratic equation in two variables, it will always be a parabola. In this case, we have one that's opening up, but we could also have one that opens down. So here's another example. Here we have y equals the opposite of x squared plus 5, and so I'll use a similar procedure. I'll use the same x values as I did in the previous example. Alright, so -3. If x is -3, then we'd have the opposite of -3 squared plus 5. Now be careful of your order of operations here. The first thing we would do is the exponent. -3 to the second is 9, and then we would change the sign. So this would give us -9 plus 5, which is -4. So we have -3, -4. If x is negative 2, the opposite of negative 2 squared plus 5. Negative 2 squared is 4, the opposite is negative 4, and negative 4 plus 5 is 1. If x is negative 1, we have the opposite of negative 1 squared plus 5. Negative 1 squared is 1, the opposite is negative 1. And negative 1 plus 5 is 4. If x is 0, we have the opposite of the square of 0 plus 5. The square of 0 is 0, and its opposite is still 0, so that's 0 plus 5, which is 5. If x is 1, we have the opposite of the square of 1 plus 5. The square of 1 is 1, the opposite is negative 1. Negative 1 plus 5 is 4. If x is 2, we have the opposite of the square of 2 plus 5. So that's negative 4 plus 5, which is positive 1. And if x is 3, we have the opposite of the square of 3 plus 5. So that ends up being negative 9 plus 5, which is negative 4. And so we have 3, negative 4. Again, considering my values for x and y in my ordered pairs, I'm going to use the same scale as I did in the previous exercise. And I'll plot the points again in blue. Let's see, we have negative 3, negative 4, negative 2, 1, negative 1, 4, 0, 5. 1, 4, 2, 1, and 3, negative 4. So notice again this is nonlinear. Notice that we do again appear to have that U shape, that parabola, but in this case notice how its orientation is different. And this one is in a sense sort of upside down. So we would get a graph, if we continued the graph, we would get something that looks roughly like this. Alright, so again we get that shape called a parabola, but this one's opening down as compared to the previous exercise that was opening up. Alright, and one more. So here we have y equals x squared minus 6x, and I'm going to start off exactly the same way. Alright, so if x is negative 3, we would have negative 3 squared minus 6 by negative 3. And following the order of operations, this would give us 9 plus 18, which is 27. So we have negative 3, 27. Alright, let's continue. Negative 2 squared minus 6 by negative 2 would give us 4 plus 12, which is 16. Negative 1 squared minus 6 by negative 1 is 1 plus 6, which is 7. If x is 0, we would have, let's see, 0 squared minus 6 by 0, which is 0 minus 0, which is 0. If x is 1, we would have 1 squared minus 6 by 1. And so let's see, that's 1 minus 6, which is negative 5. If x is 2, we'd have 2 squared minus 6 by 2, which is 4 minus 12, which is negative 8. And if x is 3, we would have 3 squared minus 6 by 3, which is 9 minus 18, which is negative 9. And if we look at all those points, notice it's still a decreasing trend, and we're expecting a U-shape out of this because it's quadratic. But let's see what we've got so far. I'm going to plot these points. Let's see, what scale should I use? I've got -3, I've got to show -327, I've got to show 3, -9. I'm going to use a scale of 3s on the y-axis. So this is then 3, 6, 9, etc. I'm going to use a scale of 1 on the x-axis. So then this would be 27 up here on the y-axis. This would be -27 on the y-axis. Let me fill in a little bit more. 12, 15, 18, 21, 24. All right, let's plot some points now. We have -327, -216, -1, 7, 0, 0, 1, -5, 2, -8, 3, -9. So notice it does sort of look like we're getting that U shape, but we should expect it to come back up soon. So let's see what happens if I use now. Let's go a little bit further. Let's let x equal 4 and see what happens. So then I would have y is 4 squared minus 6 by 4, and so that's 16 minus 24, and 16 minus 24 is -8. And so I get 4, -8. Notice now it's coming back up. So if I plot that point 4, -8, maybe you've noticed a pattern. What if x is 5? So if x is 5, what's the y value when x is 5? Well, you can go through the arithmetic, or you can notice the pattern that there's a symmetry to these curves, and you should be able to find that if x is 5, the y value is -5. If x is 6, the y value is 0. If x is 7, the y value is 7. And you can keep on following that symmetry to plot some more points. And so if we continue that onward, we'd have what, 8, 16, and 9, 27. And so we do get that U shape, that parabola. In this case, it's opening up, but we get a shape that looks roughly like this. And notice again that this one's opening up. So it would be nice to find where that symmetry occurs. In this case, that symmetry occurs about this line, x equals 3. Right? There's symmetry about this. And so we'd like to be able to find that symmetry. And so that's something we'll see in a later video.